Welcome to Engine Bard Show. How is everyone doing? Let me turn this down a little bit. How's everybody doing? Okay. So the last video there kind of stunk, I guess. And but let me tell you something. We're building a foundation. So the video itself, I admit, was terrible, but the content I do believe was pretty good. And if you're serious about that stuff, go ahead. That's why we put these timestamps. Go ahead and get to the most important parts and look at them. Okay, so right now we're almost done with this project. This one was pretty painful to do, but we are now we're about to wrap it up. This is the generate the sine wave with the DAC, the digital to analog converter. That's on the little device. It could be on Arduino, like I said. It could be on whatever, on the embed. Maybe the Raspberry Pi Pico might have it. I have no idea. Okay, so here we are. Generate. Now, here are the guidelines. I'm just trying to remind you guys of the guidelines. There was a video that did the whole thing, but I think I'm just going ahead and just sort of like, a recap of what has to get done. And this is just a recap. So they must have a title on the console. Okay. The user must be able to enter the integer and float values to the console. Okay. Must be jerk resistant, or should be jerk resistant, excuse me. And that is a very good coding practice. You always they do that in the field still. How can this program crash? So they still do that. The code should be in functional form. On the last video, both the sawtooth wave and the triangular wave, they both were in functional form. So try to understand that type of coding. I'm sure you guys do, but there's some viewers out there that might not. Okay, so you must put in a value in the steps from 1 to 4095. It's interesting. I had to learn that it's 2 to the n minus 1. When you put it in 496, it'll flatline. So I had to do all that. I had to do this. Must put in float values from 0.05 to 3.3. The user will put in the period in milliseconds. Okay, and he must be happy while doing it. So if you're happy, clap your hands. Okay, now the new command. I just learned this today. I was like, holy smokes! It's wait nanoseconds. So now this thing can go pretty fast. So instead of wait microseconds, it can wait nanoseconds. That means the wait time is in nanoseconds. Now remember, there's 100 million nanoseconds in 1 second. That is fast. Now, the quality goes down a little bit, but it can do it. And this is the fastest most can go on each transition. I got the picture of the flash there. All right, let's go to the board, and we're going to get into some more technical detail. Okay, so we're at the. We're going to do a little bit of introduction of what I'm actually doing here, and this is why I came up with these kind of crazy concepts. When I graduated, this is for people who, when they graduated from school, they either from any type of school, they go pretty quick. I'm not blaming the educational system here, but what I'm saying is when you go to like these jobs and all that, employers are finding out that the students don't have enough knowledge. They just don't have enough knowledge in a particular subject, or they don't have enough. And it's because universities do not have time. Okay, so I am here, my job is to fill in, see, this is what I call this, is the house of like electronics. It could be anything, engineering, it could be anything, it could be mechanics, it could be hell, it could even be business. I want to fill in these holes. I want to fill in these holes because they see these holes. They see the holes. You're going to these job interviews, they see these holes. So it feels so your house looks like this. Nice and complete with a solid foundation, so at least you know one topic. There's many topics, I get that. So let's go on, and we're going to go back. Okay, now we're back. So we're going to talk about creating a sine wave. These are the equations to make the sine wave. Okay, so your amplitude, you're going to find out on the next video why these equations are this way. Okay, so your amplitude is amplitude divided by 3.3 times a half. So your maximum amplitude is going to be, it's going to equal, oh, darn it. It's going to equal, so if amplitude is 3.3 and it's 3.3, well, times 1/2 equals 1/2. Does everyone see that? Because that becomes a 1. 3 over 3 then that's now 1, and that equals 1/2. Okay, so that's your amplitude. So you got your steps, 2 over steps, because inside here it's going to equal sine of your increment. Okay, times pi. So as the steps get completed, this will eventually become 2. It'll become into 1. So it'll be 2 pi. Okay. Your time is period over steps times times 100,000. No. Actually, times a million. The reason why it's times a million, because you put in milliseconds in, and what we're doing is now we have a new function called the weight nanoseconds. Okay? And that can be into nanoseconds. Okay? Does everybody understand that? Okay, let me erase that. Okay, let me erase that. Your main driving equation is going to be A out equals 0.5 plus 0.5 times the 0.5 times sine of the increment times pi. That's what it's going to be. I showed you guys on the last video. It took me a while to understand. The computer is timesing this by 3.3 because that's the voltage coming out. 3.33 volts. So it's times 3.3. You don't see that. So that's why when we go to the code talk, we're going to talk about this. So the increment will only go as high as 2. That's why it's 2 divided by the steps, and then it eventually becomes 1, and then it equals 2. Okay? So there's a for loop here for I equals, 0, and if I is less than your increment, or I is less than 2, excuse me, I is less than equal 2, then I equals I plus increment. Okay? It's going to be a little less than 2. This is where I goes actually. Because the I is 2 at the very end. you'll notice, and there's going to be a punchline at the very end of the video, okay? Like, why is this, who cares what, it's actually, so what you'll notice, the higher the increment in your design, the slower it is. The slower it rends. So your sine wave if it's a super nice sine wave, from here to here, let's say you got 1,000 points. I'm not going to put 1,000 points. Okay, dot, 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 dot. 1,000 points. Your period may be off. Your period, remember that's your period. From here to here, this is your voltage. This is 3.3 volts. May be off. And it may be off because you're trying to get it tighter. You're trying to get it tighter, but it's trying to basically go as fast as it can. So even though it says your time will get shorter to do it, but remember that when it gets tighter, your computer is working harder because it's going faster. It's faster and faster. So you're going to have to find out that in order to have the most accuracy, there is a relationship. So as steps go up, the rendering is slower. Makes sense, right? Because you're putting 1,000 points, 1,000. It has to create time. Even nanoseconds add up, and it slows down. So that's why in some video games, get to a punchline. When you see the really high-tech video games like, let's say it's the new Fallout 4 or Fallout 4 with all the high graphics, and you got to understand that the converters in there are going as fast as it can as it moves. That's why some videos, that's why a lot of people don't like that, because the processor is rendering super slow, super fast. There's a lot of points. Okay? Okay, so everyone welcome. We're not quite to the board yet. I wanted to do this first. This is the Excel part. This will give you an idea of these points. So we talked about in the last video, which, or even the videos before that, we talked about steps, amplitude, and period. So steps, the equation for steps is 2 over steps. Why is it that? Because remember that we're doing, for a sine wave, it's 2 pi. So we want to divide the 2 into as many parts as we can. I picked 20. That's an arbitrary number. So we're going to do this. But now the equation, which is interesting, is 0.5 plus 0.5 sine of step times pi. Now why is it that? Well, the reason it's that, first of all, I tried to do that, and it's interesting. I tried to use the Excel program, and you can see how I was just doing part of it, 0.5 times this, because I had an issue. right as we get over here, this was the final answer. And you'll see on the code talk, you're like, well, how come I'm putting the calculator? How come we're getting these numbers right here? How come we can't go? Why is it 0.5? Well, the reason why it's 0.5, and this took me hours. I had to think about it too. Is the computer will times it by 3.3. That's 3.3 volts. Now it makes sense. 2.6. So now when we vary, there's a ratio of your analog out divided by 3.3 divided by 2. And that will get you the 0.5. So look at these carefully. Look at these points. I think there's not much more to say. I'm gonna print these points out, and I'm gonna draw these points on the board. Let's see you there. Hi. So made a copy of, or printed it out on the computer there, and I'm reading it out. I'm giving you an estimation. So I'm gonna go really quick. But the 2.15, you see, if you graph it, if you put this onto a graph, you will see that it is connecting the dots. It's connecting the dots. And time goes forward. So the first dot goes here, the second dot goes here, the third dot goes here, and it moves forward. So this is time, this is the voltage. I guess that's a little bit of a calculus thing with the whole time, through the change of time versus the change of the voltage. So, and then as we go down, you'll see it, on the Excel, it actually cranks to be a sine wave. Very rough sine wave, but a sine wave. Now, see, it's a little bit rough. What if we got those points to be 2,000? Then it would be very squishy, there'd be little points in between here, but it's going up here. And it's going to make that sine wave even smoother. So the more points, the smoother it is, but the slower the frame rate. Okay? So I'll see you on the code talk. Welcome to Code Talk. Yeah, sorry about. So if you're coming here for the first time, I strongly advise you to go look at the pre-code or the equations there. I also have something called Code Acquire. That's for people that are students that are in a hurry. Just go ahead and take the code, bring it to you. I even show you how to acquire the code. Okay, so but for Code Talk, they're for people that just want to know, they want to learn, they want to. And it takes a little bit of time here. All right, here we go. So the first step we got to do is I'm going to go pretty quick because on the last video, I was a little bit didactic, and I don't want to sound that way. Okay, so the first thing you do is we're going to put floats, and we want to put in a file called embed.json. Remember, there's a new file. You got to right click and embed. I already put all that in there. It's embed app.json. It's interesting that I always see these videos on coding videos, like which language to learn. I should learn. Don't learn coding. Learn algorithms, because a lot of this stuff, like Java and hold on, like Java and C++, they're all pretty much the same thing. The only thing that's different is the syntax. So learn algorithms, and it's a little bit, learning algorithms is far more abstract. Okay, let's go back. So we're going to develop a sine wave. This is the sine wave part. And the first thing you want to do is, you want to declare your variables, analog A out, PA4, of course. There's the clear screen. We showed you that many, many times. It's best to memorize it. It's very important because we don't want the code to just keep blasting all the way down towards the ground, because it will. And then we want the home screen. We want it to clear it every time. And let's go ahead and develop our function. This is a long one, folks, so just kind of bear with me. Void sine wave. We want to make sure that the user puts in a period, steps, and amplitude. Okay, and look at all this stuff that we have to declare. We've got to declare the I, the increment, amplitude, amp, my time, my period. Now, I just call that stuff. You can call it whatever you want. Like I said, you can call it. Make sure you put the float pi inside the sine wave. I tried it outside here. It didn't work. So put it inside here. And the float I has to be on the outside because this is going to be a counter. And for some reason, C++, they like it when the I is out here. I'll show you that a bit more. Okay, so we're going down. You put amplitude. Now we put period equal period, my period. Why am I doing that? So what we're doing is we're transferring, we're assigning it. The period is now assigned to my period. So now it's a different variable name. We're a different place in the memory. And so what we're creating are called, these are the while loop traps. I discussed that on the last video there about the triangular wave. I highly recommend you guys seeing that. So I'm putting it, so we're creating a trap. Period, my period, amplitude, my amplitude, steps, my steps. And then I notice there's a part of the equation, my period over my steps equals my time. I discussed that. And it's my time times a million. We're putting it in milliseconds. So it's just easier for the user. It's a lot easier to understand milliseconds than actual than like microseconds or nanoseconds, and then it gets like, oh shoot, how many, you know, it takes a lot of effort to think on that part. Okay, so now we're creating here, this is the trap. This is a while loop traps. There should be as many traps as there are, as many as the user can put in. So if there's 3, you put in 3. If there's only get 1, then they get 1. If there's 2, so on and so on and so on. So if time is less than -1, because there's no such thing as negative time now. I don't know. Maybe you're watching something on Nova that there is, but not in the old coding world. Okay, so printf, if you please print in a larger value. That's the error message. And then now it's my period. If it screws up, it goes back to my period, and then it will do it again. Once, if this is if it's greater than 1, or if it's 1 actually, if it's just 1 or greater, then basically it will ignore that. So it'll do the same thing towards the amplitude. We discussed that in the last video there. It'll do the same thing with steps. Believe it or not, it's actually 495. 495. It's to the n -1. If you do 4096, if you put too many steps, it will the DAC can't handle it. It's like, I can't do all that. And it's just, so remember, it depends on the resolution of your DAC. Okay, amplitude over 3.3f divided by 2. I discussed that on the board. And remember, an increment is 0.2 over steps. So once steps gets to 2, once it gets to 2, it will basically it will create the wave. Now I created this weight in nanoseconds, and now it can go really fast. So for here on out, we can actually, I might use that instead of weight microseconds, but I'm just so used to doing the weight microseconds. I find this a little bit kind of an overkill. So, but it's all personal preference. I think you get probably better results if it's weight microseconds than weight nanos. But remember, it has to be in integer, so it has to be a whole number. Okay, it can't be a float, anything like that. So int main, int steps, float amplitude, period, clear screen, and then here we go. All right, so that's it. Now let's go ahead, and I'm going to go quick. Let's go to the top. All right. All right, so take a picture of that. This is the code acquire now. Take a picture. Okay. All right, take a picture for all people. All right. We're going to go down here. Take a picture, print screen or snippet or whatever it is. And go ahead and down to here and take a picture. Okay, let's go to the proof section. All right, so there you have it. That's a sine wave right there. Yeah, it's that'll do it. So we're going to do a little disclaimer after this. Okay, so this is the punchline. This right here, everyone's like, oh yeah, big deal, it's a sine wave. Yeah, who cares? Do you know, what would you, but that's only one digital analog converter. Imagine if we had thousands of them. Thousands going one way, thousands going one way, hitting a pinpoint on each section of the screen. What do you call that? That is how they make graphics card. Thank you. What we're going to do in a few weeks, maybe a week, hopefully shorter, is we're going to put it all together and we're going to create all the waves all into one system. So I'll see you on the next Engineering Bart Show.